Hello, let's talk about some basic geometry terms and definitions. First one we're going to discuss is a point, which represents a location in space indicated by a small dot, usually having a capital letter with it. If we're going to name this point, we're going to call this point A. Next one's going to be a line. Okay, a line extends infinitely in opposite directions as indicated by the arrows on either end. There are an infinite number of points that are on this line. We only have two that are indicated with capital letters, and then we have this scripted letter C over here. If we're going to name the line, we're going to use a miniature symbol for a line, and we're going to say line AB. Somebody else could name this line BA. Nobody says it has to be alphabetical, it just has to have two letters that are on the line. If we're going to use this scripted letter C here, we're going to call this line C. Now we're going to name this following line in as many ways as possible. So we used the way to name a line up here, small symbol of a line with two letters that are on that line, only two letters. Okay? Nobody says they have to be alphabetical, so there are actually 12 different ways to name this line right here. Next one is a line segment. Line segment's a part of a line, has a beginning, has an end, it has endpoints. How are we going to name this line segment? We're going to name this with two letters, but we're not going to put arrows on the end. QR or RQ. That's the two ways to name that segment. How many different line segments do we have in this figure? Well, we have segment AB. Segment AB goes from here to here. We have segment AC, which is a completely different segment than segment AB. AC goes from A all the way up to C. We have segment AD, A all the way over to D. We have segment BC, starts at B, goes to C. Segment BD, and last but not least, here's BD. Segment CD. Segment CD just goes from C over here to D. Again, nobody says they have to be alphabetical, so AB could be called segment BA. Okay, so there are 6 different segments on here, and this segment can be written this way or as BA, as well as the rest of them could also. Let's talk about array. What do we notice about array? Looks like it's a part of a line, but this arrow indicates that it goes on in one direction. Okay, has at least 2 points on the ray. When we want to name the ray, we're going to name it with the end point going first. Okay, it's very important. Ray FB. If the ray was pointing to the left, let's say, how are we going to name that ray? Well, the symbol goes to the right, end point gets written first, followed by any other point that is on that ray. If the ray were going up and down, how are we going to name this? Symbol goes to the right, okay, and another point that's on that ray. What are all the ways this whole ray can be named? Well, the end point of the ray is A, so it's going to be A, R. Another way we can name it is ray AM. And a final way is AY, because how do you name a ray? With 2 points, end point going first. AR is right here. Okay, AM is start at A and go through M, so they overlap. And AY is start at A and go through Y. Is ray AM the same as ray RM? Well, let's highlight AM in blue. There's ray AM. Starts at A and goes through M. and RM starts at R and goes through M. So are they the same exact ray? Answer to that question is no, because they have different starting points. Okay, so you're not highlighting the same ray. Next one are opposite rays. Opposite rays is referring to two rays that have the same starting point but go in opposite directions. So the opposite rays in this drawing would be ray BA, starts at B, goes this way through A, ray BA, and ray BC, starts at B and goes through C. How about BA and AB? Would they be opposite rays? Well, let's see. Well, BA starts here, goes that way, and ray AB starts at A and goes this way. So are they opposite rays? Well, they go in opposite directions, but they have this little part here that overlaps each other. So they are not considered to be opposite rays. Opposite rays have to have the same starting point, okay, and then go in opposite directions. Collinear points. Collinear points are points that lie on the same line. So here's our rule. Any 2 points are collinear. Any 2 points, okay, are collinear. Are Q and R collinear? Yes, because you can draw a line through any 2 points. Now, once you throw a third point in there, then you have to take a look at the drawing. Are M, N, and O collinear? No, you cannot draw one line that goes through all 3. However, up here you have A, B, and C. Are they collinear? Yes, they are collinear. Okay, so 2 is always a yes. Anything above 2 you have to take a look at. Non-collinear points. Okay, non-collinear points are points that do not lie on the same line. Okay, points that do not lie on the same line would be like this example right here. Okay, these 3 are non-collinear. All right, let's talk about a plane. A plane is a flat surface which extends in all directions infinitely, usually designated on drawings with this shape here, which is a parallelogram. Notice we have a couple of points, points A, B, and C, which are indicated with black dots and capital letters, and up here we have a little scripted letter. So if we're going to name a plane, we need to take 3 letters that are on the plane that are not collinear, and we're going to call this plane ABC. Now there are 6 different ways you could have organized this, right? Plane ABC. So you could have also named this, you have to write out the word plane, plane CBA. And there are multiple other ways of organizing those letters. That's just 2 examples. Now using this scripted letter up here, we could also call this plane M, okay? Now coplanar points are points that lie on the same plane. All right, and here's our rule. Any 3 points lie on at least one plane. Key here is at least one plane. So if anybody says, hey, are points A, B, and C coplanar, your answer has to be yes, because they said 3 points. Next one is going to be non-coplanar points. Okay, non-coplanar points are points that do not lie on the same plane. In order for points to be non-coplanar, you have to have at least 4 points. Let's talk about this. Why do we need to name the plane with 3 non-collinear points? So let's talk about this top plane. How do you want to name this top plane? Well, we're going to say plane A, B, H. A, the B, and the H are not on the same line. A is back here, B is over here, H is over here. These 3 points are non-collinear, so they are on just one plane. Now, could I name the top plane FGH? Now, the problem with this is we're not allowed to name a plane with 3 points that are on the same line, and here's why. Because plane FGH, these 3 points are on the top of the box. These 3 points are also on the front of the box, so we cannot determine which plane they're talking about, okay, because it's on multiple planes. If the points are all along the same line, they are on an infinite number of planes. Let's talk about intersect. Intersect in geometry means what geometric shape is created when the figures come together. So line 1 is made up of a series of blue points, okay? And line 2 is made up of a series of red points. What is formed by the intersection of two lines? Well, these two lines come together and they form a point. So the intersection of two lines is always going to be a point. What is formed by the intersection of two planes? So let's take a look at the top plane here. The top plane is made up of a whole bunch of red points. And then this plane on the right hand side, plane CBF, is made up of a bunch of blue points. Now, do the blue points and the red points ever touch each other, overlap each other? They do. They overlap each other right along this line right here. Okay? So what is formed by the intersection of two planes is always going to be a line. Intersection of two lines is a point. Intersection of two planes is a line. Anything above that, you have to take a look at each individual drawing. Let's take a look at this one. Is it possible for two planes to not intersect? If yes, name two that do not intersect. Well, the top of the box, we're going to call that plane. We have 4 points. We have a lot of choices here. Plane ABC. Remember, name of a plane, 3 points. They can't be along the same line. Okay? Plane ABC. And the bottom of the box, I'm going to put my and symbol here. And how do you want to name the bottom of the box? We're going to call that plane EFG. So the top of the box and the bottom of the box, or maybe you said the right-hand side of the box. How do you want to name the right-hand side? CBF works. And left-hand side. What do I say for the left? ADE. I'm going to tell you there's 4 points on the top of this box. How many different ways is there to name the top of the box? 24 ways, okay? 24 ways. So there's lots of choices. Lots of choices of combinations of 3 letters. Last question. Are points A, B, and G on the same plane? Are points A, B, and G on the same plane? The answer is yes. Remember before I said any 3 points lie on at least one plane. There's the plane right there. Great job on this section. We'll see you on the next video.